Hello, my Algebra 2 lovelies. I miss you guys a bunch. So wanted to say hello before we take some notes. Going to look at word problems with logarithms today. So, all right. We're going to look at exponential growth and logarithms and then how they work together. These should be familiar, especially this one over here from Algebra 1. These are some exponential growth formulas. So they both have A's. A represents the final amount that you end up with after a certain amount of time. The p-value is the principal. That's how much you start with. R is going to be the rate. Typically, we have a rate as a percentage. So if my R value, they tell you like 25%, we're not going to put in 25 as the R. We have to convert it to a decimal, which would be 0.25 for my R value. So you always got to convert. N, this equation has N twice in it. It remembers the number of times that the interest is compounded. So we're going to do an example. But like if something is compounded quarterly, that means that you get the interest 4 times a year, but not the full interest. You get 1/4 of it 4 times a year. And then T is time. T will be in time unless otherwise specified. So I will have some other problems where there is different T values, but it tells you how long T is. And T is my exponent for each of these, because it tells you how long you do something. So if you remember like exponential growth, it has an asymptote and then it like shoots up really high. If we're looking at growth, decay goes the other way. So we're not going to look at decay today. But like if my exponent is 4, then I would look at, getting it once, twice, 3 times, 4 times, whatever that value is. There is another formula here, which has the same P for principal. E is a number. The number is 2.71828. We're going to talk more about this at another time, but know that there's another exponential formula. R is still the interest rate as a decimal, and then T is still time. This you only use if your interest is compounded continually. And it will say compounded continually. But we're going to focus on these two to start off with for today. This one, if it is just an annual, 1 time a year, you get the interest. And this one, you have some sort of quarterly or monthly or weekly, whatever it happens to be. All right. So we use exponential growth and logarithms to find different things. So exponential growth would be if I knew what I started with my interest rate is and how long I wanted to be in there. A logarithm will help me solve for my exponent, because anytime I write a logarithm, it equals the exponent. So we're going to do an example. So let's say that Miss Ticey got $1,200 stimulus check recently, and she's going to put it in the bank, and it's going to earn 3% annually. And I want to leave it in the bank, and I want to end up getting $2,000. So if you put money into a bank, an interest accruing account, sometimes they call those CDs, cash on deposit. I think that's what they're called. Money market accounts, the bank will give you money for keeping your money in there, but you got to keep it in there for a little bit of time. So I want to take my $1,200 stimulus check, and I want it to earn $800 and give me $2,000 with this 3% interest. So I'm only getting the interest annually. So the equation I'm going to use is this one. So A is the final amount. I want my final amount to be $2,000. The initial amount that I have is $1,200. Then I have 1 plus my interest rate, so it's a 3% loan. So I need to change that to a decimal. You always move it 2 places to the left, so 0.03. And then how long do I keep it in there? So without using a logarithm, I can take my calculator, and I can use some guess and check until I get 2,000. So I can do 1,200 and then 1 plus 0.03. Let's say I leave it in there for 5 years. I don't have the $2,000. So let's say I leave it in there for 10 years. I don't have the $2,000. Let's say I leave it in there for 15 years. I'm getting closer, but I still don't have it yet. So I can use guess and check to find out using my exponential. But if I turn this into a logarithm, it makes it a lot quicker to solve. So first thing I'm going to do is combine these two values. I have the 1 plus my interest rate. So I have 2,000 is equal to 1,200 times 1.03 to the t power. So this is an exponential. And the base of my exponential is this 1.03. This 1,200 is a coefficient. I'm going to move it to the other side. I'll move it to the other side by division because it is being multiplied. So 2,000 divided by 1,200. I either want to use all of these decimals, and it's a repeating decimal. I'm going to use it as a fraction, so 5/3. I don't want to round until the very end because it will affect my answer. So I'm going to leave it as a fraction, 5/3. And this equals 1.03 to the t power. So this is an exponential. I'm going to turn it into a logarithm. When I turn it into a logarithm, the base of the log will be the base of my exponential. So this is going to be log base 1.03. The exponent is always what my logarithm equals. So it's going to equal t. And what I'm taking the log of is what I want my exponential equation to equal. So 5/3. So my calculator doesn't have the fancy button where I can use whatever base I want. So I'm going to have to use my change of base formula. So if you recall, the change of base formula, if I have log base a of b, where a is my base and I'm taking the log of b, I write this as a logarithm divided by a logarithm. My base here is going to be 10, so I'm not going to write it. The old base value goes in the bottom. So it's like just moving this to the bottom with its own logarithm. So to convert this so that I have a base 10, I'm going to write log with base 10 on the top and the bottom. My old base was 1.03, so I'm going to put the 1.03 in the bottom. I'm going to put my 5/3 on the top, and this is going to tell me how long it's going to take. So with my fraction, I'm going to put in log and then 5/3. And then the bottom log and then 1.03. And it will take 17.28 years. Just going to round it to 2 decimal places. So if I take my stimulus check of $1,200 and I leave it alone for 17.28 years, really, I'm not going to get it at the end of the 17th year. I'm going to have to wait for 18 full years because I only get it on that anniversary date. And then I'll have $2,000. So let me just check and make sure that this works. I'm going to go back up to my exponential equation up here. So if I start off with $1,200, times 1 plus 0.03, and I raise it to the 18th power, I should have over $2,000. And I do, 42 to spare. I want to show you that if I raise it to the 17th, it won't quite get there. And if I raise it to the 17.28, it's a little bit closer. So it'll round to 2,000. But 18 full years will get me there. So taking an exponential equation and writing it as a logarithm will help you solve for the exponent. So let's say that I take the same stimulus check of $1,200. I'm going to put it into a bank that earns 2.5% interest, but I get the interest quarterly. So I'm getting a lower interest rate, but I get the interest 4 times a year. I don't get the full interest. I actually get 2.5% divided by 4, but I get that 4 times. I'm earning a little bit more interest. So let's see how long it'll take to get that same $2,000. Starting with the same, a lower interest rate, but I'm getting my amount quarterly. So I'm going to use a different formula. The one with the n. Technically, I could use this and the other one because my n value would be 1 if it was just annually, because r divided by 1 is just r, and 1 times the t is just the t because the n is t. But, all right, so my final amount is $2,000. My original amount is $1,200. My interest rate, if I move my decimal 2 places to the left, so 0.025, and that needs to be divided by 4. The 1 does not get divided by 4, just the interest rate. And then my exponent is 4 times t. Okay, so I'm going to go ahead and combine these again. I'm going to use my calculator to help me out here. So I need 1 plus 0.025 divided by 4 as a decimal. Oops, I didn't mean to put an equals there, sorry. So this is 1.00625. Please do not round until the very, very end of the problem. It will affect all of your work. And then my exponent is 4t. I'm going to divide both sides by my 1,200 again. This was 5/3. And then 1.00625 to the 4t power. I'm going to write this as a logarithm. This number is going to be my base. So log base 1.00625 of 5/3 is equal to 4t. I can use my change of base formula to solve this out. So I'm going to write a log in the numerator and the denominator with base 10. My old base value goes in the bottom. And then the 5/3 stays up here. This equals 4 times t. So when I get my value, I'm going to have to divide by 4. But let's see, we'll have log of 5/3 and log of 1.00625. So 81.98724,739 equals 4t. Really, don't round until the very end. I'm going to divide both sides of my equation by 4, since I'm getting this a total of 4 times t times, or t is the number of years. So if I divide by 4, I'm going to round this to 2 decimal places. 20.50 years. But so really, since I get it at the quarter, half is part of a quarter. So 20.5 is my answer. I'm going to come back up and check it with this. So starting with 1,200, 1 plus 0.025 divided by 4. And I'm going to raise that to, I have 20.5 times 4. So that's my years times my n value. So I kind of do this backwards. And I should get $20,000. I've got some practice. Please let me know if you have any questions.